for adding subtype for 82.15.4, and those subtypes will be distributed for among different SDOs. And we also need to consider about wrapping up the ND update requirements that came from Pascal's document, and that would result into updating RFC 6775. And so to conclude, I just want to mention that we had a successful plug test event right after IETF 94 conducted by HC. And we are going to have another presentation by Karsten at the end of the session to give you more details. So the next presenter is Ralph.
So how many of you have read the draft? Come on, come on, come on. You have no excuse. It's 1 page long. It was, I couldn't quite get it. If it had been one author, I would have gotten it on 3 pages. But I had Paul Duffy on it, so it got to 4 pages. All this does is ask for an ether type from IEEE. RFC 4944 encoding does not include a protocol switch field anywhere, and that causes some problems. There are a couple of different organizations who would like to have such a protocol switch.
Oh,
and because of some bureaucracy stuff, it turns out that the best way to do this is for IETF to go to IEEE and formally make the request. So all this document does is say, hey, we'd like to get an ether type for RFC 4944 6282 encodings. I'll say more about that in just a second. And as soon as we get consensus, we publish it as an RFC with IETF consensus. We'll send that request off to IEEE. Now, this has been discussed on the mailing list. I got some really helpful input back. In particular, there was a question about exactly what would this ether type apply to. And what I've done is I've rewritten the text a little bit so that now it says anything that uses the RFC 4944 dispatch byte is covered by this ether type. So that's it. So that it covers 6282 and anything else we might do that all fits within that first dispatch byte. If we want to do something else in the future to separate one kind of encoding from another, we can do that later. This is just sort of the legacy, well, not really legacy, but what we have currently for 4944 and related encoding. And I think that's about it. So I'll let me answer questions first, and then we'll have the chairs talk about the plan. Karsten.
Karsten Bormann, can you actually run 6LoW over Ethernet?
Why not?
Padding?
What does that have to do with this document?
I have no idea.
Let's just worry about this document, okay?
Shouldn't this document have something like a disclaimer about?
All this does is an ether type. It's not telling you how to run it over Ethernet. It's just getting the ether type.
Right.
Okay?
So there needs to be some other work on actually making it work.
Not my problem. Somebody asked me to get an ether type.
Good to know.
Okay, other questions? So, Shel, you want me to explain the plan?
Yes.
Why don't you go ahead, you're in charge.
So we would like to move this document forward as Zigbee NAN requires it pretty soon, right? For their deployment and IEEE specification. So we'd like to take a vote today. Vote meaning poll hands. Raise your hands if you think this document is useful, and we would like to work on this document and make it a working group document. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, and is there anyone who doesn't think that this document should be a working group document? Okay, so we will send email on the mailing list and we will confirm. Thank you.
We'll give it a week, 1 week confirmation on the menu.
And then I would like to ask the working group then to take it to a working group last call as soon as the working group has adopted it as a working group work item. I'll have the renamed version of the draft ready to go. I'll publish it as soon as I get the go-ahead from the chairs, and then start a working group last call, and then we can give it to our, maybe this will be your first one, Suresh. This will be an easy one. We'll start you off easy. Evan? Oh, it won't be your first one? Okay. Thanks.
Thank you. Okay, so next presenter is Tero Kivinen.
So, this is not directly related to 6 law. It's related to IETF in whole. So, but 6 law is one user of this, so 60s and core and co-op or something like that. So, this is similar than the previous one, meaning this is allocating one number from the IEEE. And this case, we are allocating as this 15.4 information element number. If you go to the next slide, yeah, okay. So there is information elements in 15.4 that allows you to transport any kind of traffic inside the frame separate from the payload itself. So you have information element at the beginning and then you have payload. So and this allows you to put things that either in the same frames or as a separate, so it doesn't get mixed up with the payload. And they have been seen that in several cases in IETF protocols we might have interest of adding some stuff into the, before the payload or instead of a payload, that would be separate, so we would be able to separate it from that. To get information elements, we have to fill in the request for the IEEE, asking them to actually IEEE 15.15 ANA, which will allocate the number, but we need to provide them a request and say that, okay, here is how we're going to subtype it, because they want to say that they only give us one. There's 16 of them, they don't give us more than one. So we have to provide them a way to say that, okay, we are going to subtype it ourselves and it's clear that we don't need anything else than this one number. And then we also, need to, I think there was we have to understand that, yes, we are not getting anybody else. There's 2 types of information elements. There's a header IEs and there's payload IEs. And I hope that IETF protocols don't mess up with things that we need header IEs. So that's why this only allocates a payload IE, which is something that we probably won't need. I don't think there's anything else. There is a picture in the bottom that shows you how the information element is going to be, subtyped. So we have 8-bit, subtype field, and it's going to be IN allocated registry. And I updated the version of the draft already and added there, and it's going to be expert review for the allocation for that, because I think that's the correct allocation procedure for that. And I also added some links to the all the ANA and operations manuals and so on for IEEE. So if people want to go and see how the process actually is supposed to be working out, it's easier because the links are there. So I think that's all I have. Any questions?
Okay, thank you, Ted. So next presentation is a remote presentation by Katie Lin on 6 low back document. So do we need to give him access?
Are you showing the slides from that end, Sumita? Good.
Yeah.
So first slide.
Career, you see, his stuff. Okay. Okay.
Can you hear me?
Yes, we can hear you.
Yeah.
Okay, great. So I know that time is short today. I just want to focus on this motivation slide for one moment. The original motivation for doing IPv6 over MSTP comes from BACnet, which is the international open standard for building automation, commercial building automation. And it was the only major data link in use by BACnet that didn't already have an IPv6 specification. So that's the genesis of this. The The actual draft predates the 6-Low working group, and I think served as a template for several of the 6-Low proposals that came afterward. I think in the interest of time, we'll skip over the next 2 slides.
Two slides, did you say?
Yep. Skip.
This one?
Yep. Okay. So, as I said, this was first presented in 6-man as an IP over foo proposal back in July of 2011. At this point, we have somewhere between 2 and 3 interoperable implementations. Kontiki and Riot were tested against each other in Yokohama. Karsten, in his copious spare time, I think, got somewhere along the trail with implementing this as well. There's also a dissector implemented for Wireshark that cracks the encoding. There are no external dependencies remaining. We only had one BACnet assigned the frame type to us, and there's a new update of BACnet coming out this year that will have all of the changes that were made to MSTP and that specification all integrated. But there is a draft available right now of Clause 9, which describes MSTP, that has all of the modifications in it for anybody who wishes to get access to it, either implementers or reviewers. We've already had 2 detailed reviews, Peter Vanderstock and I'm spacing on the other person who did one. I apologize to that person especially. I think Karsten wants to take a final look at this, but at this point, only the security section remains unreviewed. So I'd like to talk about the use of privacy addresses in 6-Low for a moment. As Samita said, I submitted comments on the privacy draft, and I think I try to make a case for the fact that a lot of the issues that have been raised in other forums like 6-man don't really apply, I think, in the M2M case. For example, I don't think it's a problem that we're going to be leaking link local addresses and email headers, but I put a lot of those issues to the mailing list. But the bottom line is that in this draft, I try to assume that most of my recommendations have been approved by the working group, and that the only place where I say in this draft that we should be using privacy addresses is for off-link or for routable addresses. I think that's really the only case where we're going to be exposing information to outside adversaries, is at L3. So anyway, I propose that we keep normal Slack for local traffic, especially since it affords us the maximum efficiency for IP header compression, and that really is the use case, or the main use case that I see for MSTP is basically as a local field bus for sensors that are communicating back to a controller. I mean, of course, they could, potentially MSTP could be applied to other applications as well, and in that case, if they become clients for servers out in the internet, then you would want to use privacy addresses, but mainly in that case alone. So next slide. Right. Yeah, very little is new. Maybe this slide should have gone before the other, but anyway, I think last call has come and gone. We didn't really hear any comments on the list or otherwise. As I said, I think Karsten still wants to take a look at this, and so we'll be open for comments probably for another week or two, but I think that's it. I'd like to hear from you if you have issues.
Any comments for Katie? We didn't have exactly any comments during the last call, but I remember that Karsten has promised to review your draft and give some comments. Okay, Karsten is nodding yes. So as soon as he gives that comment, and then probably we will write up the Shepherd's write-up and then proceed from there. Thank you.
Okay.
Okay, thank you, Katie. Now we are back on time. So next presenter is on NFC. And you can use this one for switching between slides.
Okay, thank you. Good afternoon, everyone. My name is Yonggun Hong. I present the IP-V6 of NFC. So I think that you are familiar with NFC because the NFC are basically included in your smartphone, Android phone cases. So in NFC, there are three modes. So we are targeting onto peer-to-peer mode. But usually, many NFC cases are utilized by read-write mode and NFC card emulation mode. But if we deliver packet, we must use the peer-to-peer mode. Okay, is the history and status. In the last year, March, it was adopted as a working group document, and this is the third version. So in this version, some typo fixed, and section 7, security consideration was added. Yeah, security consideration. So from this document, the privacy consideration document, the various threats such as correlation of activity over time, location tracking, device-specific vulnerability explanation, and address scanning. So in NFC case, NFC use short address, 6-bit address. So, and a set of well-known concurrent bits such as padding with 0 and for the modified UI64 format. So it can be exposed from the various threats. But if you think about the characteristic of NFC, however, NFC technology is operated single touch-based approach. It means that extremely very short-lived links. So we think that this mitigates the threat of correlation of activities over time. And if we think about the use case of NFC, not used for fixed size data transfer or multimedia streaming, long-lived links, but used for ID verification and mobile payment. It means that extremely short-lived links. So the 6-bit short address of NFC link layer is not generated as a physical permanent value, but logically generated value for each connection. And every single touch connection can use a different short address of NFC link. So we think that this feature can mitigate address scanning as well as location tracking and device-specific vulnerability explanation. And just for information, in the last meeting, in the HG6 Pro test, we joined with the 2 implementation, but unfortunately, we only passed 2 items. So in the Berlin meeting, we hope to pass the remaining items. And informing the MS forum, so we got response from the email response from last year, October, and we will participate in the NFC forum meeting on the June, the Texas. So in that meeting, we will inform them of the work of in the 6th row and ask to some feedback before the working group last call. Okay, so it's our next step. So we would like to ask to is ready to working group last call, and we will prepare at the second HG6 Pro test. So in this test, we will targeting on the pass the remaining items, and in this case, we have some further considerations such like that. Okay, that's all. So question and comment.
Actually, I have one question. You said that for security, I mean, that it depends on the NFC technology because it's short-lived connection and short range. Does it use any other link layer security for connection, or it's not secure at all?
It's not, it's no other specific secure mechanism.
Okay. And you think it's fine because of the small range and frequent change of the addresses? Or in future, do you need some security at the I6 low pan layer?
Okay, it's a good question, and also I'm thinking about, but in the currently, if you think about the characteristic of NFC and think about the use case of NFC, it is not a problem of the security. So, so I'm in the June the NFC forum meeting. So we will ask any feedback for regarding of this. So in the next very meeting, we will report about them.
Okay. Thank you. Actually, we are looking for 2 volunteers who would read the draft and then will give comments during the last call when we make that call. Can we see any hands for volunteering? Okay. Thank you, Pascal. Anyone else? Okay, all right, Alex, thank you. Okay, so I'll write that down.
I have a quick question though. Who wrote the 2 different implementations?
One is mine, and one is the co-working the small company in Korea.
Ah, okay.
Thank you.
Are you going to use the clicker? Do you want me to? I can just
Sure,
open it.
I can. Unless you want to present it. And I didn't change the name of the draft. Okay, so we are going to talk about the new escape byte dispatch that is defined for new escape byte types, mainly for ITUT, and we have also defined some of the other bits and its usage. So basically we are in version 3 now. We have completed last call. We have received several comments. And before going to that, I just want to give a quick background to people who are new in this working group today. So ITUT G3 PLC reported that they have already started using some escape bytes in their implementation and specification. They are using mesh header, but they are using escape bytes with the code space for type 1 to 31 numbers. And they want to preserve that, and they came to IETF to request that we cannot change that. So we had several discussions, and the liaison statement sent from ITUT to IETF. You can take a look at that. So this is the new types that we have recommended in this draft. So we had a few comments from ITUT by Thierry Lace, and mostly those are editorial fixes, which has been taken care of. And the other major comments are from Pascal Thubert, who pointed out that the escape byte should not follow low pan IPHC dispatch type payload, because that will create problems with fragmentation calculation. So we took the recommendation and we changed the draft text, and every time the escape byte appears along with slope and IPHC dispatch type, it will always come before the dispatch IPHC dispatch type. So that will not create any problems with the fragmentation. This is to have compliance with RFC 6282 and its rule for compliance. And then the other part that we clarified is the NLP behavior, non-low pan is dispatch type behavior. And just to make sure that if it is a non-low pan packet, it won't be applicable for escape. And so just to clarify those. So next step is ISG submission. Our shepherd is Jonathan Hui, and we are requesting him to write the write up, and after that we are going to, I think Suresh is going to handle the rest. Any questions on this? Okay, thank you.
Pascal?
Hi, I'm Pascal Thubert with Cisco. So we've been a long way since Honolulu when we were trying to figure out how we would compress the ripple artifacts into the IPv6 packets encoded with 6LoWPAN. And we ended up with this paging mechanism, which allows us to extend the encoding space that we have in 6LoWPAN. This is different from the escape, because the escape doubles the size of any code you want to place, because it has to be escaped and then you place your new code. The paging mechanism says, okay, when you see this new page value, from there everything is encoded within that page, and then you can switch page and switch page. We only use page 1 for the time being, and it's only used by the 6-layer edge.
Is this the right slide?
Yes, should be. Okay. So the news is that we've split actually this encoding to keep it at 6-low, and we moved the 6-layer edge discussion to roll. So far, all the problems were solved for one single document, and you will find all the issues actually solved in the ticket page of the 6-law working groups. So there is no active ticket at the moment. And the update is pretty simple. Now we've got these 4 bits set to 1 and the last 4 bits to give you the page number. That's pretty much all there is in this document. So I really encourage people to just have a short read, just like for Ralph's document, to make sure there is no stupid mistake in what's left in the text. The only change that I'm expecting to see for now from the comments I've seen is that the author list will be extended to include Robert Craggy, because it was missing so far. Forgot to place it. So that will be fixed when we publish. And like I said, the typical use case so far is the 6-layer edge, which uses a third of the space in page 1. Okay, and one little change that happened is the INR section was not properly written initially, so now it's been fixed. If there is something that, yes, could attract your attention as a reviewer, would be to actually look at this INA section.
Anything else?
Questions?
So just wanted to mention this completed working group, let's call on Friday, I believe. There were very little comments. We are still waiting for a few more, just to make sure that it's okay. It's not a very complex document, so you could do it between, on a coffee break. Even if you just say, yeah, looks good, that's fine. But we should be going to ISG pretty soon, I think. It's pretty simple, so, thanks. You're next?
You are next.
Then stay there.
No, next is Sahib.
Really? Routing header, that's what I have.
He already completed, right? Did you, or for routing header, did you already? I think you already addressed the routing header. Did you want to have something more on that? No.
I guess, yeah, the only thing we need for routing header is from this working group, make sure that it uses the paging dispatch.
Hear me now?
That's all.
Yeah, okay. I removed the microphone. So it didn't work.
Microphone.
So can you show my slides? Because I still see the old slides.
Shahid? Shahid around?
He is remote.
Oh.
Shahid, are you ready? We cannot hear him.
Now, shows me the old slide from NFC. Your
Hello?
I don't know.
Mute him now? Okay, now, yeah.
Okay. Then I use my slides and
Quality
I
is
will
not very good if
tell
you
you.
speak closer
So I'm on the first slide
to the
now.
mic, that'd be better problem.
Okay. So I am on the first slide now, and this draft is about the compression of IPv6 edge and ESP headers.
Can you
Now
see
I
the
can see my slides.
slides?
Good. So next slide. Yes. A quick history of this draft. This draft was first presented in IETF 80 during
We are showing your slide
workshop
here, but
just before,
maybe you
IETF
can
80.
just tell me
And then
which
it
slide
was
you
submitted
want
to
to
the sixth
go.
law
and
working
go
group,
on.
but that was the time when sixth law working group was about to close. And then
And speak
some
slowly
of the drafts
because
from sixth law
your
were moved
voice is
to
breaking.
from the sixth law pan were moved to sixth law, and this draft was included
Yeah.
in the sixth law draft. And then I presented this draft on IETF 93 and then 94. We have addressed the comments which were raised during the IETF 93 in IETF 94. And in this presentation,
are on the
I
next
will
slide.
mostly focus on the comments which were raised during the IETF 94. Next slide, please. Some of the unique features of this draft compared with the other compression mechanisms available for IPsec is that this draft is designed for 6 low-band networks only, which means that we do not require any changes in the current IPsec implementations on the internet side. So this will enable end-to-end compatibility with any IPsec-enabled host on the internet. There are other proposals like this 6-low-band DITE, which requires a change on the internet side, and ROSC as well. These were the comments which were mainly raised during the IETF 93, and then we have addressed this in our draft during the 94. But
Yes,
all these available or other solutions, they are actually complementary to our solution, and none of them is specifically designed for the 6-low-band networks. Next slide, please. So I will focus my presentation on this slide, and if we have time, I can move on. So there were 4 basic main comments during the IETF 94. The first comment was about the AH authentication header, that it is almost not used today. So why should we include it in this draft? So the comment was we should stick to ESP and not include the AH. Carsten has already answered this question during the IETF 94, but now we have included a paragraph on AH in our draft, and the main motivation to use AH is that, according to us, it makes more sense because in the current internet today, which is IPv4 enabled, so we have nets. Once we have nets, then the AH actually breaks because the integrity check fails. Therefore, the AH is not used in these netted networks, and IPsec today is mostly used in tunnel mode on the internet. And in that case, you know, the AH make less sense because the basic difference between AH and ESP is that AH can protect the IP header part as well, where the ESP can encrypt the payload and protect the ESP header and the payload. But once you use the tunnel mode, then the entire internal packet, which includes the IP headers as well, is protected by the ESP. So then it's exactly, then the ESP gives us same level of protection for the actual end host as the AH can give. But in the IoT domain, or in this network of 6 low-PAN networks, we educate end-to-end security using the transport mode of IPsec, which means that ESP alone cannot protect the IP header part. And therefore, this is one of the reasons we include AH, and at the same time, at IPv6, we have no nets. So these are the 2 main motivations to include the AH, and I think AH make much more sense in this 6 low-PAN networks than the traditional internet. So there are a couple of paragraphs on this in the draft as well. I'll be happy if someone review and give comments on those paragraphs. And then there was another comment by Carsten that the ESP NHC ID bit we have used, it is already allocated by IANA. And I would say that this draft is quite old. So I think when we first used this bit, it might be unassigned, so that's why I used it. But it's a simple solution. Now we have used one of the free bits. So this is resolved. Another comment was use only one EID reserve bit and make the other bits extensible. If someone has seen the presentation, or we might go to the slide a bit later how we solve this. So in the EID part of the NFC, we have 3 reserve bits, and we can use those for 8 different values. 6 of them were already assigned, so we had 2 reserve bits. And in the last presentation, we had 2 options, either to use both reserve bits, because those were for IPv6 extension or IP extension headers, and both AH and ESP are IP extension headers. So it makes sense to use those for these extension headers because these are defined by the IPv6 protocol in the same sequence where these two reserve bits come. But the comment was that we should not use both bits, but use one of them. So that was also the proposal during the presentation. So we are now using one of the reserve bits to represent this. And then the actual header is whether it's an AH or ESP header, which is distinguished based on the initial ID bits. So that's also solved. One comment which was actually related to some of the results, experimental results we shown, that we should not use ECM, we should not use the control mode or counter mode or the CBC, but that was just for yeah, we were going forward, but that was just for one of the experiments. Our IPsec draft does not recommend any specific cipher suite. Actually, it doesn't depend. So it's just the compression of headers. The actual cipher suite it depends on the whatever standardized source port on the internet side or on the constraint device side. That's outside the scope of this. So we do not recommend any specific cipher suite. So we only stick to the header parts and compress them using the NHC style of 6-LoWPAN standard. How many minutes I have now? Yes. So I can quickly go through these slides. So in 6-LoWPAN header compression, we have these slides were already presented, but I guess the people who are here, or maybe Samita, you can go a little forward because this is presented 2 times before. Yes. Or maybe then I start taking questions because all the slides, the rest of the slides, I have already presented them in a couple of IETFs. So I would be happy to take past questions then.
Yeah, I think you have 5 to 7 minutes. So. Okay, you can tell me which slide to go to, but right now I see Pascal is on the microphone. He has some question for you.
It's dedicated to discussion, but yeah.
Pascal Tuber, Cisco. I just have a question about how you think that this work should be used, because my question really relates to which code would actually perform the IPsec work. Do you, because IPsec may encrypt what's right after. If you use your ESP, you will basically hide the upper layer protocols. And if you hide the upper layer protocols, then you cannot compress them with 6-LoWPAN. Unless
I think we have mentioned in the draft as well.
The decryption should happen within 6-LoWPAN.
It's
the
not,
tension is
it's not compressed.
if you just want
so we are compressing the bits which are
restore
not
the
part of the
encrypted
payload.
IPv6
Yes, it's
packet,
fine,
still
yes.
encrypted, then
And we still
6-LoWPAN
give some
cannot
numbers how
compress
much
the
we
transport.
can save both on AH
And
and
whatever
ESP
is
side,
after the ESP header.
after this encryption.
On the other hand,
after
you may want to say,
we compressed
I
unencrypted
restore the ESP
parts.
header. Now I
So
can
yes, you're right. I mean, if it's an encrypted
decrypt
part,
and maybe
because
the rest
we don't
contains
expect
also
any change on the internet
6-LoWPAN
side.
compressed.
So we are not expecting that I mean, one of
But
the
that means
solutions
that
to,
the
to
ESP
support this
work
encrypted part
happens
as well,
within
to
the
have a new
6-LoWPAN
cipher
work,
suite,
which makes it
which
then
are
complex.
actually supported on the internet
So what's your
side,
take on
and
this?
then you can compress those. But those are outside the scope of this draft. This is not touching any encrypted data inside the ESP payload.
Hi, this is Hannes. I'm wondering on whether there's enough interest in a working group to work on this in the first place. This is something I have been wondering about for years already, and I haven't been at all the meetings, but yeah,
I think that's a fair question. Maybe we can have a quick show of hands to gauge interest in the working group. How many people here would like to work on this, see this going forward, implement it, deploy it? Who's interested in this going forward? Let's see, 5-ish. 5. Who thinks this should not go forward in the working group? 3-ish. 4. And so
yeah, and I would like to understand why some of the people who raised their hand, or why they think that, for example, my Ericsson friends, why they think they should go forward, because they sponsor a project together, or it's because you also work on some of the DTLS stuff, and it provides pretty much the same functionality. Like we already know from the rest of the work in the IETF that DTLS and TLS has very similar properties nowadays. And what I would hate to see is that we create artificial fragmentation in that space with the security mechanisms, and we then suddenly someone has to implement all that stuff. And I don't see these implementations happening on these IoT devices. Just because it's possible doesn't mean that we need to standardize everything.
I would like to respond as well.
So you have objection
to
of having security done.
And I think Hannes is putting this question, and we had this debate not today, but for years now. Even when the DICE working group was not formed,
that's not what I said.
And there was discussion whether we should have IPsec or DTLS. And they are absolutely on two different layers. I mean, DTLS, one of the most important attacks in IoT is the IP spoofing attack. And DTLS cannot
implemented it all. Now we are just in the phase of moving over to TLS 1.3, which is
so this IPsec is a should be implemented protocol in IPv6.
In another group,
there is no discussion on whether we should have
now we need to work on IPv2 and
DTLS or link layer security or object security.
All these resources come
all these different works,
they have different
pros and cons. So what IPsec can do, for example, DTLS cannot do. I mean, for example, for applications where the programmer should be completely agnostic about security, then IPsec can solve this problem. You know, you could have an IPsec solution. Yeah. Sorry, yeah, Carsten.
we need to keep the answers short. I'm going to cut the line right now where it is.
Carsten Bormann. I'm co-chair of the core working group, which has decided to do its security based on DTLS. We had a section in the draft for a long time that described ESP as an alternative security solution for CoAP, and we decided to go for DTLS for a number of reasons, and I think most of these reasons are well known here. Now, having said that, I think the use of ESP in this space is often a little bit of a chicken and egg problem. We are saying we can't use it because we haven't done the work, and we don't want to do the work because we can't use it. I think it's actually quite useful to have a way to use ESP in this space. There are some applications of ESP that make a lot of sense, in particular on a constrained device. Most of the problems we are having with ESP really aren't with ESP at all, but with the weird way that ESP, that IPsec has originally been integrated into our larger systems kernels. So I'm pretty much in favor of completing this work, so just that we have another tool in our toolkit, even though right now, as a core user, I wouldn't know how to use it. But there may be applications where it's useful to have it. And given that it's almost done, I think the effort for getting it completed is worth it.
I think one of the problems, I think IPsec is very useful in using in these environments. I'm not sure if it's actually useful to compress it too much. I mean, the hero compression, what I was looking at, what this, for example, does, the SPI you can't compress because IC version 2, for example, takes it randomly, it's 32 bits, so you can't compress it. You need to have some kind of dynamic compression to, if you want to compress it more, something like, okay, the first, some negotiation in IC or something like that to, tell which SPI is going to be using. So make it pay a mapping from big number to the small number or something like that. But for example, the robust header compression for IPsec, I think does already. The serial number, it's about the same thing. There is, it says it's incremented. It doesn't say it actually is incremented by one every time because you might lose lots of packets in the middle. So it's a little bit, difficult to do that. Serial number is actually something that you can, very easily, because the one who is sending the packet will see all the packets he's sending out. He notices if the, if there's a big cap, and he can use the bigger serial number for that. But anyway, so it's a little bit more of okay. Using IPsec here is one of the good things. For example, is that, as we said, that we had a 15.9 coming out in IEEE, which allows you to use IC version 2 as a key negotiation mechanism in the 15.4. And if you have that one already in, then using that same mechanism to generate end-to-end keying to the cloud service or something like that is also, possible. And it allows you to run, IPsec from the IoT device to the, end-to-end, and using the same library to actually negotiate to the, to the link layer security. So I think there is a, use for IPsec, but I don't think if it's actually how much we can actually benefit from compressing it.
Just a couple of points from the Java room. The first one is Caroline. The advantage of IPsec is to support secure multicast. This could be one of the advantages. And the second point from Michael Richardson was in Russian room. I think this IPsec work should be deferred. I don't think we should allocate 2 code points until we have a reason to. But 1 code point on experimental, I could support that. I support that very said.
The multicast for IPsec is dead. We discussed this in DICE for a long time, and the conclusion was made that this is not particularly useful. We then investigated an application layer solution, and that's what we have been writing up. I have no idea why Sandeep is still posting solutions drafts that describe the multicast. It seems a hobby. I don't know. But in the IETF, at least, that was the conclusion before closing the working group, that it will not be done. So on the key management for the 15.4 stuff, that's also a problem with 15.4 is that there have been basically a laundry list of mechanisms defined, key management mechanisms defined. You are not helping people for interoperability if you give them so many different options. And I think that 15.4 is already in enough trouble if you compare that from the sales figures of other technologies like Bluetooth Low Energy, and they are now adding their mesh specifications. So I'm worried about the future of 15.4, and creating this continuous mess is not going to help them.
Just for a quick answer to what was said.
Very quick, because I had closed it, basically. I had closed it. So
Yes,
10 seconds.
I can go. Just the point is, Tero's point about the fact that the keys or the mechanisms actually can be reused for from the layer 2. That's true, and but that works also with transport. ISA 100.11a using the same CCM star technique at layer 2 and layer 4.
Yes,
Doesn't
please
mean you
send
have
an
to
email
do it
and
at
happy
layer
to
3.
reply to on Hannes'
I
comments.
agree with Hannes. If you want to multiply the ways of doing things, you will fragment the market, and you don't have so much space in the devices that you can afford to implement all those things. And one thing that did not really show up is we
That's
have
more
only
than 10
3
seconds, Pascal. We need the time, that's the problem. So I sense there's a lot of passion around here, but I don't sense like this is a slam dunk yet, and we've been saying this for years. So I don't think, was that? Okay, we'll continue to the mailing list. Okay.
Okay, so do you have any comments, Suresh? No.
He said
Okay,
mailing
say
list.
mailing
We'll
list.
talk on the mailing list. Okay.
Okay, thank you, Shahid. We will take it up in the mailing list. Thank you.
That's fine.
Now it's Pascal, backbone router. We are on time.
Okay.
Do you need this one?
Okay, so news from the backbone router. The backbone router, as you know, is a very ancient work. It really dates still since the 2008, something like that. It was initially part of what became 6LoWPAN-ND, was separated, and we said we'd work on it later, and now we are actually doing it. This is a 6Low effort. It's related to a number of other efforts, in particular 6TiSH, where we actually expect to be demonstrating or testing the functionality at the next ETC plug test. The text also was updated slightly to reflect the fact that it is of general value for wireless. There is all this discussion between the IEEE and the IETF, the IEEE IETF coordination, about the problems that come with the way IP uses multicast on wireless. And if you consider this, ND was defined at a time where Ethernet was doing transparent bridging, which means that the MAC addresses, when they were not known by the bridge, would result into a broadcast over the switch fabric. It was only natural to do the same thing at the IP layer. When you don't know the resolution, you just broadcast things until you find. That's the way things were done at that time because of the kind of networks. The 802.11 is really the protocol that introduced the breakthrough of having what we call the association process, whereby the bridge function inside the IP is now populated proactively. So the IEEE made that effort more than 10 years ago, and IPv6 in general still has not made the same step. And the backbone router is exactly that. It's how I can do an association with my router, so the state which is used to route to my wireless device is proactively installed into the router, so you don't need to do all this multicast broadcast operation, which leads in these problems on the wireless. If you look down to it, what we have here is a layer 3 access point. And to actually enable this function, we had to slightly extend the arrow option, things which we discussed, like I said, before 2010 in the 6Low working group. The idea is probably that we should split those changes to 6775 into a 6775 update. That's something that we are discussing.
Yeah, that's something the chairs have discussed with Pascal.
And so the document as it looks now is really 3 documents in one. One is really an explanation, why are we doing it? A lot of words, which will not end up in an RFC, or not in a standard track RFC. It's just too chatty, but it explains why we are doing this. Then there is the piece which implements 6775 requirement. And that's the piece that we could actually take into a 6775 update. And then there is the real proxy operation by itself, whereby we use 6775 updated to create this state, this association state in the router. And now we can do ND proxy operation or any other operation like inject this into a routing protocol. And that's it. We don't have so much time, so I won't steal your time on this. Then again, we get this plug test in Berlin, and if people are interested in implementation, then I encourage you to start now so we can test together in Berlin. There will be a router implementation of this, so if you have a radio technology, you have a dongle that can plug into a router, please come to Berlin with your implementation and we'll do an intro test. Questions?
Okay, so that was short. You have the next one too. This one you may want to explain the mechanism so people can understand.
Yes, we discussed with the chairs this morning and we found that going through my slides about the gory details of things could be of interest, but not the most interesting thing to do with this meeting. So rather than saying exactly what the changes are or what the draft does, probably we want to discuss a little bit in this room of why we are doing this and what we're trying to achieve. So there is such a thing as SAND, Secure ND in IPv6, and the goal of Secure ND is not to encrypt the packets or do the traditional authentication identification that we can expect from security layers. What it does is ensure that if somebody owns an address, then that will be that same somebody claiming it over and over, and nobody can claim this address, impersonate this address, and get the traffic. So it's really about avoiding an attacker to spoof an address and get the traffic routed to it instead of the rightful target. And this is a complex feature to achieve in normal IPv6 ND because you have to protect any peer-to-peer communication, because every device talking to another device will cause a ND cache entry to be created in the target device. So it's always possible, even if you can't fool device A, you can still try to fool device B by claiming that you own this particular address and get the traffic redirected to you. That's complex because of this peer-to-peer nature of classical ND. Now, with 6LoWPAN ND, things are different. With 6LoWPAN ND, we've got the 6LBR, which is a registrar. And the registrar can actually ensure, and it does, that when somebody comes in with this unique ID that is in the other option, then only this somebody can later claim this IP address. It's associated in a state in the 6LBR. But the problem is people can fool the 6LBR if they forge the UID. If they know the original unique ID of the device, then they can fool the 6LBR and steal the address. So what we really want to do at the core of this document, what we really want to do is actually create an ID for the device that can be used as an anchor for IPv6 addresses, but also for any other information that would be associated to this particular device, like a name or something else. If we have this trusted anchor that only the device can claim, then the 6LBR is capable when somebody else comes in claiming that he's this UID, wants this IP address, the 6LBR can actually validate if this guy is really this guy. If this guy is really the guy which formed this address in the first place. Okay, so what we are really doing here is creating a trusted anchor, a real verifiable identity to the device, that at any point of time in the future, the 6LBR can challenge the device and say, are you really this guy? And we want to use it as the unique ID in the arrow option so that now it is impossible to steal an IP address from a device. And in the future, we'll be able to associate that to other information, and all those information will be packaged together with this trusted anchor. So it's really a highly, incredibly actually powerful tool that we are bringing to 6LoWPAN with this trusted unit ID. Okay? A short remark here is there are a number of protocols around here, like ISA 100.11a, which were looking for a way to identify a device. They found that, okay, if I identify my device with a MAC address and I want to replace this device, then the MAC address will change. Unhappy, I can't use the MAC address as the unique ID of the device. I don't have room for names and complex stuff. So at the end of the day, ISA 100.11a uses the IPv6 address of the device as a unique identifier. Well, IPv6 addresses may be spoofed, and anyway, it's not. An IPv6 address is not an identifier. It's not meant to be. What we have here is one trusted anchor that a device can prove that it holds. Okay, so it's probably a much better way to make sure that a certain device is this certain device that we think it is.
Hi, Pascal. This one is, I think often this identifier discussion is very confusing because what is always needed to be said is, what are you going to use that identifier for? What's the purpose of it? And so it could be, for example, in some cases, you may want to use some identification of the device when it runs the authentication protocol at the server. And so obviously, whatever you hand out as identifiers at that server, it needs to be unique. What the structure of the identifier is by itself doesn't matter. In some other cases, you may want to use them for, has also some routing components. So you may actually, like an NAI or something similar. And then it's obviously very different. The story is very different. But I think for most of the purposes, it actually doesn't matter what the identifier is. Because you're hopefully not going to have a structure assumed in there. You just use it in your authentication protocol. Like, for example, pick up in DTLS with pre-shared secret authentication. You just have that.
Okay, so I need to answer, before you go further, I need to answer what you already said, otherwise I won't just
overflow.
Remember, yeah, exactly. So the word identifier is really misleading here. What we are creating is a trusted anchor to any data that we want to register for that particular device. And the cool thing, what we really bring is the protocol to test a certain device and say, prove that you own this identifier, this trusted anchor, so that you actually, if you could prove that you own this trusted anchor, it means that all the information that I have as a 6LBR associated to this trusted anchor is actually owned by you. So it's not like a string, it's actually a cryptographic information.
You're describing regular send.
I'm describing it's not regular send as some protocol, but really this thing is like a CGA. Right. But it's not used as a routable address, it's used just as a trusted anchor. Because we've got this registration mechanism, so whatever you register, you can say, oh, I'm registering this, but the trusted anchor, the guy who owns this, is this. And later, if somebody comes in and wants to claim the same resource, you will have to prove that he's the same person. The 6LBR doesn't know who this person is, but it will check that it is the same guy.
Yeah, and you're purely talking about the IP layer here, right? You're not assuming that would bubble up to some application layer, or do you?
Well, maybe not to the application layer, but the applicability to names is obvious, right? If you want to say, I'm Pascal, and I give this crypto associated to this name, and the LBR says, okay, now Pascal will be this guy for life. Well, it will be able to validate that. It's a trusted anchor for some data that the network needs. So I'm saying just it may go beyond an IP address, on several IP addresses.
Eric, not Mark, but it's not really a string like Pascal, right? I mean, these, just like the CTAs, it's really used to prove that you're the same one that's registered the first time, right? And that's what we have today with an untrusted mechanism by just putting in a UI64 there saying, okay, I have this one. If I come back again, connect to some other LR, LBR somewhere, the fact that I present that same clear text EUI64, the protocol then says, oh, you're the same guy and you moved, as opposed to someone else trying to register the same address, right? So it's only that distinction between, is it the same node or not? And what this does compared to what we have with EUI64, it says we can actually challenge and secure that because it's effectively a hash of, some public key or whatever, right? Just like in CJ. So, but it's not proving that you're Pascal, you're proving you're the same guy as registered before.
First time, right.
Yes.
It's a trusted anchor for everything I want to register.
For me, it's okay if it's what you just said, Eric. If it does that, if it doesn't do other things, then that's good.
And I don't know whether there's higher level protocols that care about that same property, that you can prove that you're the same guy as before. There might be, right?
Or at least if they depend on the IP address to go to the same guy. Now, because the 6LBR ensures the correlation between the IP address and the same guy, now we know that talking to that address will always lead us to the same guy, right? So
yeah.
You can.
So that's then the area where I get concerned when you want to sort of reuse the same stuff at the higher layers, because different endpoints, all sorts of different properties, what happens when it changes and suddenly you can't change it at the lower layers because you have bound it to the higher layers and so on. So that's why I'm concerned. But if it's just what you, Eric, said, then that's good.
Pascal, you want to go through your slides or not?
So I have a question on the previous slides, Yeah, so Pascal, how do you protect the compromised node here?
Oh, no, it doesn't. If the node is compromised and so alien code starts using the stack, that's not protected.
Okay, so what is that here that I understand that during the registration time you're getting the identifier, but you're not addressing the compromised node problem, right?
No.
Okay.
It's really some other node connecting to the network and trying to get the traffic to your address to be redirected to him. And the 6LBR will not let that happen. So we said that. So changes to the document. Yes, that's basically answering questions we had on the mailing list, like how is that different from sound? Won't that cost 1 KB per registration? And the answer is actually no, because as long as there is no contention for a certain resource like an IP address, there is no need that you're the person who owns this particular crypto ID. You only need to prove it if there is somebody challenging you, like another device claiming the same address. Or this device has moved and you want to make sure that because some parameters associated to the trusted anchor, like where he is, if those parameters change, before you change the state in the network, you want to validate, hey, this guy is the same guy. So there was also this question, and we actually discussed that this morning, is it a possible thing in a network which is typically secured at layer 2, that a bad guy comes in and tries to spoof an IP address? And well, I think we kind of came up with the answer that yes, it's possible, because even if it's secured at layer 2, it's a wide network. There is a large variation of the way things are deployed. And the quality of the setup in terms of security may vary dramatically between a home network and the factory. So the quality of protection we expect in a corporate network from the fact that there is a layer 2 encryption may not actually protect any IoT device against bad guys getting it. The layer 2 security is just the first wall in a series of walls which protect the integrity of the network operation. Having this method to prevent snooping is a second layer of security in the middle of a number of layers of security that we have to put in place. But then if people want to come to the mic and discuss that, that's actually a core point in this discussion.
Yes, so Michael Richardson on Jabber, the value of this security is that it protects against misconfiguration by operational people. And Caroline adds, it's a fine line between misconfig and attack.
There's always, but in case of a misconfig, I mean, it really depends. If the guy misconfigs the IP address, I mean, if you misconfig all the parameters, you reduplicate the configuration of a device, that will go down to the keys which are used to generate this ID. So unless there is a random, and we have to discuss that, which is really runtime random, which goes into the forming of this, then the two devices may end up with forming the same UID from the same key. So it's actually a good point to discuss on how we form this ID to actually detect that. So it's a great point. Thanks, Michael.
So Michael Richardson again. It's a typo when you set up the new network management service node, the new NMS node.
I don't hear. It's a typo if we what? Which slide?
Which slide? I don't know. Which slide he's talking about?
So I actually saw something weird in my slides.
He's responding to Kerry. They're having a dialogue between Kerry and Michael.
Okay. So probably if you isolated just one mail, we've concluded that. Just go a little bit to the flow if we have time. Do we have like 2 minutes for flows?
5 minutes, five
Oh,
to
5
10
minutes.
minutes.
Good. So I actually show the flows the way things happen. And I need to turn here. Sorry. So this is basically the way the network starts. I mean, there is this array which can be broadcasted. So that's how you get your compression state for the context, for instance. The array may be broadcasted, or it can be actually, and often it is, obtained through after an RS. And the potential change for this specification is that the array would indicate that the router supports this particular functionality, so that you actually register with the updated 6775. It's not really mandatory. We could live without it, but that creates a restriction in how we do the registration later, and I will explain. And later is now. So the main change in that is that in the arrow option, the UID, the unique ID, is now obtained with this CGA-like crypto, and there must be a bit somewhere which will say, oh, I'm updating this support. So far, the specs just says, because we have other things which come together, a single bit does it all, but we may decide that we want a particular bit to say the address is a crypto-based address. Well, the UID is a crypto-based UID. And now this flows through the arrow exactly like it does today with 6775. So that's a 6775 flow carrying an arrow option with a new crypto ID. Just a point which is interesting is that the 6 backbone router, so the previous draft, actually uses the arrow option over the backbone. So because we do that, we can also validate the uniqueness of the ownership based on the arrow option over the backbone. So what we are describing in the 6-LOPAD network also applies across the whole backbone. And that's the answer. Then again, it's the same flow as today, with the backbone router included. Okay, so and that's when interesting things come into play. First, you may have a policy in the 6LR which will automatically always validate a claim for a crypto UID. So this is an example which is illustrated here. You get this registration. The UID is said to be crypto, and the 6LR has this policy, so it's a choice to actually validate it on the fly. So what's going to happen is, instead of forwarding the NS in the form of a DAC exchange to a 6LBR, the 6LR will kind of reject the NS with a status code that says prove yourself. And that's when the device will actually create this much bigger, like 1 KB of data, NS, with the proof that is the owner of the UID. And the way it's proven is pretty much sound, 3971 or 72. Then the 6LR can actually check this, and that's a stateless operation. And if it's okay, then it will actually start the data exchange and register to the 6LBR. What's interesting there is that the 6LR, if there is a trust relationship between the 6LR and the 6LBR, then the 6LR can indicate that it has validated the unique ID, which saves the burden of sending all this 1 KB of data from the 6LR to the 6LBR. And second flow. So that's the one I have multiple flows in the slides. Okay, so that's the case where there are two devices claiming the same resource to the same 6LR. So the 6LR finds that there was this registration maybe with this unique ID, but without the claim from being a crypto ID. And somebody else coming in spoofing maybe the same crypto ID, and another 6LR has to make the decision which of those two guys is actually the real guy. And that's when it will challenge exactly as we said. This may also happen on the 6LBR. This is when the attacker and the attacked are actually attached to two different 6LR. So the 6LR does not see that there is a collision. Only the 6LBR, which is the point where everything converges, can see. So at this point, it has to be a status 5, back from the 6LBR saying, hey, go and challenge this guy. Until the challenge is made, there is no reason for the 6LBR to update its state. So the 6LR will actually reject status 5, the DNS, and if the newcomer is actually the real owner of this crypto ID, then he will be able to validate it. And then again, the 6LR will update the state in the 6LBR. Okay. So if somebody comes in first with an ID and that it has seen in the past, and for some reason the state is no more on the 6LBR, it is still possible for the real owner to come in later and get his address back. That's really what I'm showing here.
Okay, Pascal, are you done?
And same flow, validating the address against the attacker. And what's really expected is the attacker cannot validate anything because it doesn't have the crypto material. So most probably it will not happen, otherwise it will send some shit, and anyway it will be thrown out. And that's it.
Okay, so let me ask, how many people have read this draft? Okay, only 3 hands or 4 hands I can see. So among the people who have read this draft, do you think this is useful, useful document to work on?
Mohit, I reviewed the draft and sent my comments on the list already. I do think it's useful.
So maybe if you did not read the draft, maybe you can have an advice whether it's something we should be doing in this group or not. Okay. Now that we've spent the time to explain what it is.
Yeah, we will take it in the mailing list, and of course we would, if we would like more reviewers, more people to read this draft, or maybe then we can decide where to take this work.
We should add the flip question: does anybody here think this is not interesting? Shouldn't go forward? Okay.
Carsten Bormann, I think generally the basic idea here is useful. What I haven't really thought about is how this integrates into the greater security flows that you would use in a constrained network. So for instance, I don't understand how exactly you do crypto agility and so on. So I think it requires some thinking about the right way to do things like onboarding and so on when you use this. And I think that thinking should be done, and then we should go ahead with this work.
Thank you. Oh, there is one more comment, quick.
Yeah, so Pascal, I was just thinking that what is the use case you are thinking about, that whether this kind of technique will be useful?
Okay, so the use case would be a network that does not provide a complete guarantee that you trust and understand exactly what's in the stack of every device in this network. So for instance, if the attacker is a device that is in the network and is compromised, then it may be used to black hole an important device in the network. Like if you have a control loop, you know, the control loop is between a sensor, a programmable logic controller, and an actuator. And this actuator may be critical for whatever happens in this network, like whatever this network is built to do. Now, if one device in the network can be compromised, and you know, like I know that the stacks, the small IoT devices are far from perfect. Now, if one of the stacks is compromised, or if a device is introduced in the network by mistake, you know, you buy something on eBay at home, you just install it at home, you provide the key, that this device can do a lot of things. So what we're trying to do is limit the scope of attack that can be achieved by a compromised device or a device which was let into the network by mistake.
Yeah, so I would like to take offline, but I think that's what I got up earlier and asked that compromised node question, right? So I do not understand that if a node is compromised, that node will have the same ID.
No,
which is
it's a different node being compromised, right?
Okay.
The attacker will protect against a node being compromised and now serving as an attacker to black hole a non-compromised device. I can do nothing if the device that I want to protect is compromised.
Right.
But what we can do with this is that if there is another device which is implanted in a network by compromising an existing device or by injecting a new device into the network, we are trying to limit the sort of attacks that this device can do remotely against the network, typically here a denial of service.
Okay, so you are assuming that the compromised node is basically the owner of the other nodes which are actually installed in that environment, which is basically, you know, directing the traffic on this. Okay.
And yes, you want to use this compromised node to attract the traffic from the node you want to attack. That's why we mentioned compromised nodes.
So the keyword would be defense in depth, and classical neighbor discovery just relies on all the nodes in the network to be friendly to you, and if one isn't, you have a problem.
And in a corporate network, maybe you can expect that from PCs. I don't know, because there are viruses, you know, and I know. But on an IoT network with a lot less upgrade measures, etc., that can be, there is a lot more opening for some sort of attacks like this. So we really need to provide all the possible layers of defense.
Okay. Okay, let's move on, and we will take it in the mailing list. And more people need to review the document, make comments. Thank you. Sorry? So next is use cases.
Okay, this is the 6-row use cases.
Jumping.
Okay, is this the history? So you know the 6-row use cases were discussed from IETF 89. So, but unfortunately, we have no related document after that. So in the last meeting, we submit in the 00 version. So in this time, we revised 01 version. So in this version, Carlos Gomez and Go Dong-young were added and author. And 6-row link layer technologies, we add a new one, the LTMTC, because it is only related to IPv6. The other LPW technology in the current, there are no direct relationship between IPv6. And design space dimension, deployment bootstrapping, traffic pattern, and the power usage strategy and the limitation was slightly modified or new added. and currently we have 5 6-row use cases. Okay, the goal of this document. So in the currently, there are lots of the working group document, 6-row and IPv6 document. So, but unfortunately, in the last IETF meeting in Yokohama, in the first 6-row blog test, the implementation is not was not fixed, because even though we are using new 6-row technology, but some person asked me, "Oh, do we need IPv6 on this of the link layer technology? What's the benefit?" So I'm thinking about, and I can say something. But if we have some good document, that it is more easy to persuade them. So that's the goal of the document. So the first goal is to describe the specific information of the 6-row uses and how 6-row PAN requirement can vary on different L2 technology use cases. And second goal is to describe the practical deployment scenario of the 6-row technology with the consideration of 6-row layer technology. So you know the RFC 6568 was developed in the 6-row PAN working group. They have some coverage handles. And finally, we would like to inform relevant information about 6-row applicability to external audience. So in the morning, we spend discussion in the pre-session time, so some results are included in this slide. So in the currently, there are lots of the 6-row link layer technology, for example, G-Wave, BLE, DECT-BLE, MSTP, and NFC. And in this document, we make some design parameter for 6-row use cases. As you can see, there are. So if you think about, it is also valuable to consider as the design parameters. So let us know, and it will be very helpful to enhance the document. Okay, so currently we show 5 6-row use cases. If we use NFC, we think that we can deliver the secure transfer by using NFC in healthcare services. And if we use G-Wave, then we can make a smart home uses. And if we use BLE, then we can make some example for Bluetooth LE-based body area network for fitness. And if we use DECT-BLE, we can make some smart home services. And if we use LTE-MTC, it can be used for the backhaul for LoRa gateway. So I show you one example of the 6-row use cases, that is the NFC. So if we use NFC, it can make some services dominant parameter. So in this case, the dominant parameter in secure transfer by using NFC. Deployment bootstrapping is a pre-planned multi-point or point-to-multipoint or P2P. In topology case, it can be a small, so NFC-enabled device connected to the internet, and L2 mesh or L3 mesh. So original NFC does not support L2 mesh, so L3 mesh can be configured, and so on. So we can analyze the others, the 4 6-row use cases, and we can also analyze the dominant parameter of each use cases. Okay, this is just for information of the 6-row use cases. In the last February, we will request contribution of IoT use cases from JTC1 Working Group 10. So in the current JTC1 Working Group 10, they have 4 ongoing standard projects. Among them, they asked to collaborate IOS this use case, Working Group 10 and 0314. So I have met the Working Group 10 conveners, and we found that there are some differences between 2 SDOs. In JTC1 case, they want to gather IoT use cases and related actors. So it means that entity that communicates and interact can include people, software application, system, database, IT system, etc. But in our IETF 6-law case document, the focus on the applicability of the consideration of several design space of 6-law technology to efficiently implement typical IT services. So I report to working group chairs. So I'm asking what's the next step to the JTC1 working group 10. So if the decision was made, then I follow.
Yeah, we are working with Ralph Drums, who is the IB liaison manager, and we will answer to the JTC working group, and we'll talk to you as well.
Okay, good. Okay, this is the final last page. So in the morning, I have got some positive feedback. So among them, one is that how about change the title? For example, the deployment scenario and the requirement of 6 blah blah blah, not the use case, because use case in scenario is so general. So it is the first comment. And second comment is that we show 5 use cases and relevant design spaces. And then how about make some comparison table with 6 use cases? For example, 5 6-row link-array technology, and then in the column there is a design space. Then we can judge or we can identify something. Okay, so it is useful to develop the 6-row document. So I would like to ask to the 6-row person. So in this document, we missing one 6-row technology, that is MSTP. So how to handle missing 6-row use case specific link-array technology. And I would like to ask how to describe the 6-row requirement. In the current document, we don't have the requirement. But if we handle 6-row document, there are 2 types. One is the common 6-row requirement, and the other is the specific requirement of each 6-row link-array technology. So I'm asking, how about your opinion? Is it valuable to describe also 6-row requirement in this document? And final, how to develop this document? For example, teleconference or some editing group. Okay, that's all. Okay, Pascal.
Pascal Hubert. If this document moves forward like it is, first we discussed this morning that renaming it could be a good idea. But you would need to be very clear whether it's a document that's for use by us, so as to know what to do next, or if it's for use by entities outside the IETF, so it's actually a document which I sense it is right now, that is for people outside this group or outside the IETF to understand what they can do with 6LoWPAN, what is the power that 6LoWPAN brings into the IoT. And a document like that, in my view, would be immensely useful.
Okay.
A document for giving us requirements, you can always do that, but it's not the same document. So certainly, in your question, should we add requirements into this doc? My answer is no. Right? If you want to do requirements, we try. We already have some requirements on changing or updating documents, but it would not be. It would be an inward document, a document for this group, so it would not be this document. Right?
Okay, thank you.
One more question I have. Is anyone in this room or remote site who are deploying any of these 6LoW based implementations? That includes 6LoWPAN as well. No one is deploying? No? I'm asking if anyone is deploying the 6LoWPAN networks today, maybe can provide some helpful information. So, okay, you know some of them.
Caroline on the mic can provide input for MSTP. And a comment from Carlos Gomez that he agrees with Pascal.
Okay, thank you.
Thank you. Our last presentation of the day, Karsten. On time.
Okay. Yeah, there should be a monitor there. There is no monitor there. I want to quickly report from the 6 law plug tests we had at the last IETF in Yokohama. We have had a number of events where we have had plug tests of constrained node technologies. And this one was a little bit different because 6 law really is a grab bag of different technologies. So when we sit together and want to do 6 law testing, and one guy brings an NFC implementation and the other one brings a 6 law back implementation, we cannot test them against each other. So that is a little bit of a problem. When we run a 6 law plug test, we actually have to get together a sufficient critical mass for each of the technologies that we are testing. And it actually turns out that for some of the technologies, there may be other things that are getting in the way. So for instance, the DEC people at the time just had made a major change and were looking forward to running their own interoperability event a couple of months later, and so on. So in the end, what we did was we focused on 3 technologies, 6 law back and NFC as kind of new ones, and 6 law pan as an established technology. We had 9 companies. Etsy calls the organization companies, whatever. Actually, there were a couple that didn't have an implementation and just wanted to see how this process works. So maybe they will come with an implementation the next time. And the results we got may look a little bit discouraging because we only got about half of the tests done. But if you look a little bit more closely, it turns out that we had a number of optional test cases that were added, which were TCP based, and many constrained environments just don't do TCP. So maybe next time we will do something about isolating those test cases into a separate test set so the results don't look so bad. But if you just look at the interoperability part, that looks pretty good. So those tests that actually went through in the end mostly led to interoperability. We actually didn't find anything where the specs need to be changed this time. This is different from last time. But we did find a few things that we need to consider for the next plug test. And one thing is we really need to have interoperability tests for MAC layers that are non-trivial and are done in software. So we found that the join leave process for 6 law back is kind of interesting, and we had some strange results, which in the end we could reproduce after we understood that they had to do with the sequence in which nodes join or leave, and when the node coming in has a higher MAC address than the other, then something different happens than when it has a lower address. So that's where we will add some interoperability tests. And another observation maybe seem obvious, but if you are doing NFC testing, you really want to have things like tripods and isolation materials and so on, because if you are bunching 2 computers together to do NFC and those don't have cases, then you get short circuits and things like that. So that's something that we probably also want to consider the next time. Speaking about the next time, obviously, both Sixlowback and NFC have since seen additional implementation, so it probably would be a good idea to do this again. And also, Sixlowpan is growing. So how can we make this more of a regular event? We had one Sixlowpan interrupt in 2013. We had this one in 2015. We probably don't want to wait another 2 years before we have the next one. Now, the 6-ish people actually have interop events every weekend or something like that, slightly less often. We may want to take a page out of their book and make this into a regular event. So something like every second IETF. It's probably not worth it doing it every IETF, but every second IETF might be the right period. So that would mean we do it now in Berlin, we do it in Chicago again, and so on and so on. This doesn't have to be a completely fixed schedule. The more important part of it is that we know at least half a year in advance that an event is happening or not happening, because people actually, they not only have to book flights, they actually have to do work to prepare this. So we have to get a much better predictability and schedulability of these events. And of course, for every single event, we need to define which technologies we are focusing on. So this is something that still needs to be done for the Berlin event. So we're kind of late with that. And what we also discussed is that actually it's not a problem if 6-ish people are sitting in the same room with the Sixlow people. They're testing mostly the same thing anyway, just with slightly different radio configurations and MAC configurations. So that they actually can help each other, and Etsy doesn't have to run the thing twice for different technologies, because in the end the server infrastructure and so on, that's all the same thing. So the plan would be to kind of piggyback on the 6-ish event in Berlin, and then make sure we have something going for Chicago. Any comment on that?
Unrelated comment, there should be a blue sheet around with no clipboard. Does somebody have that? Oh, you got a clipboard? Okay, I still only have one blue sheet. Is there another blue sheet with a clipboard?
Oh, there is another one.
Over there? Okay, thank you. Sorry.
A short comment from Michael Richardson. 6 months notice is the most important thing when you preview the next interop meeting, to just get out this preview. And it was seconded by Caroline for this.
Mm-hmm. Thank you. Okay, so we proceed this way.
Okay, thank you. And this is the end of the session, and see you all in Berlin. Thank you. So you have the minutes, or you have the more or less notes. Would you be able to write the summary this time? Would you be able to write the summary, updating that Internet Wiki? Yeah. Thank you.